Alright, today I will be solving the AMC 8 1987 questions. What am I up to? 16 to 20. Joyce made 12 of her first 30 shots in the first three games of this basketball game. Her seasonal shooting average was 40%. In her next game, she took 10 shots and raised her seasonal average to 50%. How many of these 10 shots did she make? Alright, so we were given the total amount of shots she had before she made these 10 shots, which is 30, and how much of it she made. And we see that 12 over 30 is equal to 40%, as they said, as the question stated. So after after the next game, she made 10 shots. So that's the total amount of shots was 30 plus 10. So this season she's made 40 shots, and it raised her seasonal average to 50%. So we want to figure out uh how many what is 50% of 40. So we can see that 40 times 50% is equals to 20. Because 40 divided by half is equal to 20. So that means that she made 20 shot. She made 20 of her 40 shots, and she already made 12. She already made 12. That means that of the 10 new shots she made an 8 more, because 12 plus x, which is the amount of shots she made in this next game. So new shots made is equal to 20. So x here is equal to 8, which brings up her seasonal shooting average to 50% from 40%. Abby, Brett, Carl, and Dana Darna are seated in a row of 4 seats numbered 1 to 4. Joe looks at them and says, Brett is next to Carl, Abby is between Brett and Carl. However, each one of Joe's statements is false. Brett is actually sitting in seat number 3. Who is sitting in seat number 2? Alright, so we know that. Alright, so for these problems, we always want to have like placeholders for their names, so we know where's where. This will be number 1, 2, 3, 4. Alright, so let's first start off with what is actually given, which is Brett. Brett is actually sitting in number 3, sitting in seat number 3. So Brett sits here, and let's figure out the rest. So so we know that Joe's statements are false. So we know that Brett is not next to Carl. That means that Brett cannot be in seat 2 or seat 4. That means that we can also eliminate Carl from the answer. And thus we know that Carl is in seat number 1. Abby is between Brett and Carl. So this means that Abby cannot be in seat 2, because that would mean that she is between Brett and Carl. So Abby has to be in seat 4. And we can also eliminate Abby from this list, Brett from this list. And there is actually enough information to figure out, because we know the last one, Donna, is supposed to be in seat number 2, and our answer is D, Donna. Half the people in the room left. 1/3 of those remaining started to dance. There were 12 people who were not dancing. The original number of people in the room was. So we know that. Alright, let's work with what we have. So we know there's 12 people who were not dancing. 12 not dancing. And we knew that 1/3 was dancing. This means that the remaining number of people are these 1/3, are the 1/3 people who were dancing, and the 12 people that were not dancing. We know that. So this plus this is equal to 1. This means that the 12 represents 2/3 of the people, because there was one third of them were not dancing, so the rest of them was 2/3. And from this, we can figure out that 12 is equal to 2/3. That means that 1/3 of the people so we can actually figure out the number of people there. So my brain's lagging. 12 times 2/3. This is equal to 4. This is 8. Wait, that doesn't make sense. Wait, I mean it's 2/3 x, because x is the total number of people, which you don't know, is equal to 12. We can't do this with 1/3 because we don't know what 1/3 of people are. So if we multiply this by 3/2 on both sides, we get, this become 1, this becomes 6, we get 18. We're not done yet because 18 is only half of the people. Because remember, in the beginning the question said half the people in the room left. That means there's another 18 people. So 18 times 2 is equal to 36. We were able to figure out that there was 18 people in the room that were left because we knew that 1/3 was dancing, and then that means that the other 2/3 were not. And using this information, we can figure out how many were actually in the room. Alright, next question. That's another calculator question. A calculator has a squaring key x squared, which replaces the current number displayed with its square. For example, if the display is 3 and the x squared key is depressed, then the display becomes 9. If the display reads 2, how many times must you depress the x squared key to produce the display number that is greater than 500? So, in this question, we can just write out the steps. So originally it will read 2, right? So if you hit it once, it will become 4. Hit it again, becomes 16, because 4 squared is 16. Hit it again, it will become 64. Wait, it's not 64. 16 squared is 256. So this is the third time. And after you hit it for the fourth time, we can clearly see that this number becomes big, like really greater than 500. And if we did that, let's be precise. I just did it. It's become 65,536. So after 4 button presses of the x squared, the displayed number is greater than 500. You can see how quickly this escalated. '20 reads, if a whole number n is not prime, then the whole number n minus 2 is not prime. A value of n which shows this statement to be false is blank. So we have to see if a whole number n is not prime. So we have to see which we can first eliminate the numbers that are prime, which are 13 and 23. Because this statement only works if n is not prime, and 23 and 13 are both prime numbers, so they won't work. So what we want to figure out is we want to take one of these composite numbers and subtract 2 from it, and then the answer has to prove this statement wrong. N minus 2 is not prime. So if we want to prove it false, then that means that n minus 2 has to be a prime. So we have to find the value that it does that. So we can see 16 minus 2 is 14, 12 minus 2 is 10, 9 minus 2 is 7, and obviously 8 A is the correct answer here because 7 is a prime number, which proves that this statement is false. 10 is 10 times 5, 2 times 5. 14 is 2 times 7, which both are not prime, and they wouldn't prove the statement false. And that's it.